Welcome. So today we'll be talking about solving simultaneous equation with three unknowns. So here, this is a very valid question. To explain this topic using this question. So here we see, consider the equations given. Now, comparing what's the denominators here and the denominators here, we can now say that the determinant change in 1, change in 2, change in 3, and change in 0 are equals to these denominations here respectively. Going on, writing the equivalent of change in 1, change in 2, change in 3, and change in 0, literally we have this. So we say change in 1 is equals to determinant of the coefficient of matrix obtained from omitting x. Same goes for y, z, and the constant term. Moving on, we highlight our equivalent. Now, the cocoa of the matter begins. These equations have been given earlier on here, so we just bring them here and do the needful. Here, the only thing constant is our constant. The only thing constant is our constant. So let's proceed. Solving equation 1 and equation 2 simultaneously, we eliminate x so that we can now have two variables that we can solve for and get our y and z respectively, then come back to get x. This may look like a long process, you know. Multiplying equation 1 with a1 and equation 2 with a2. So now we are in the process of eliminating x, and in eliminating x, we multiply the equation 1 with a1 and equation 2 with a2. Remember, in our secondary schools, then they tell us that to multiply two equations, we multiply it by the coefficient of the variable. Yeah, to eliminate a variable, to eliminate a variable, we multiply the coefficient of the variable in inverse ways. So when we multiply equation 1 with a1 and equation 2 with a2, we get this. Now, here we see that a1, a2, they now repeat themselves in the two equations as the same. Okay, let me come again. If you notice, in these two equations, the coefficient of x is the same in the two equations, thereby making it easy to eliminate x. And then we subtract. In subtracting, these will cancel out. We are now left with these part of the equations. And of course, subtracting, so we take the coefficient of y here minus coefficient of y here, and all, and that goes on and on. Seeing that after subtracting we have the same like term in each bracket, it's needful that we factorize them out. Yeah, factorize them out. And then we have this. I would like to name this equation R1 because it will be needful as we proceed. Now, that is the first equation gotten by eliminating x. Remember, initially we had three equations. We've taken 2 and eliminated x. Now we'll take another 2 and eliminate x again. So we can now have R1 and R2. So we do the same process. Multiply equation 1 by 8 equations as the same. Okay, let me come again. If you notice, in these two equations, the coefficient of x is the same in the two equations, thereby making it easy to eliminate x. And then we subtract. In subtracting, these will cancel out. We are now left with these part of the equations. And of course, subtracting. So we take the coefficient of y here minus coefficient of y here, and that goes on and on. Seeing that after subtracting, we have the same like term in each bracket, it's needful that we factorize them out. Yeah, factorize them out. And then we have this. I would like to name this equation R1 because it will be needful as we proceed. Now, that is the first equation gotten by eliminating x. Remember, initially we had three equations. We've taken 2 and eliminated x. Now we'll take another 2 and eliminate x again. So we can now have R1 and R2. So we do the same process. Multiply equation 1 by A3 and equation 2 by A1. Remember, you multiply the equations inversely with their coefficients. And then we get this. And of course, being that we want to eliminate x, we are going to have to subtract afterwards the multiplication. Here we now have these, and then we subtract. In subtracting, we still have like terms available. Thereby, we factorize, leading us to this. Remember, we had R1 before. Now we have R2. Now, R1 and R2 are equations and they are similar to each other. And it comes like this. Bringing them together, we have this, making it easy for us to solve the equations and factorize the needful. So here, after getting R1 and R2 together, it's needful that we also eliminate another variable. Don't you think so? I think so. Eliminating y in this time would be easy, leaving us with z and our constants. Thereby, we can get the value for z. Let's go. Remember how we eliminate, so I will not want to go through the process all over again. We have this. Although this may look a little bit longer because of the many coefficients that have been allotted to these variables, so you just look at it closely and we move. Having eliminated y, we now have this, and this. Remember, naming your equations are important. Now, we rename this equation after its elimination to be R3 and R4. Subtracting these equations, leaving us with only z and our constants, will give us this, whereby we rename it as R5 and R6. You know, looking at these equations is a whole lot, and it could be cumbersome and strainful to the eyes. So then we put it in a matrix form. And in putting it in matrix form, we have these and this, making it easy for us to cancel out and continue with our solution. And then, as usual, we subtract so that we can get the so we can factorize it out and work. In subtracting, we have these and we have this. So this is our constant and this is z. Making z to be the solution formula is the next step to go. But before then, let's quickly look at this. In subtracting, as usual, we take these minus this, not these minus this, because this is the first equation. Like you follow the style, z minus z. So like you take it normally, this minus this. That's all we have here, nothing otherwise. Please be careful not to put this minus this. It could be very confusing at times. Now we go into making z the constants, rather the subject of formula. And then we have this. Oh my, the workload gets bigger. And then we have this to be z. But can we just put these as z and say we are true? No, they've already given us the format of how our z should look like. And there we have to proceed further and continue. So taking things step by step is needful so you don't have to make mistakes or errors, especially dealing with minus. That's a very annoying sign to ever work with when solving mathematical problems. So please, I advise that you take good and careful note when solving with a minus. So now we're going to start with the numerator, and then we have this. Opening these matrices out, we have this. Remember, D1A2 minus A1D2. That's how we got everything here, following the laws of matrix. Same thing applies here. B1A3 minus A1B3. As easy as that. So then we bring it out here like this, and we bring it out for further work. Okay, so this is going to be a little bit taxing as you're going to multiply these two brackets together to have a long bracket. But it's easy to multiply. I bet you it is way easy to multiply. Very easy to multiply. Step is needful so you don't have to make mistakes or errors, especially dealing with minus. That's a very annoying sign to ever work with when solving mathematical problems. So please, I advise that you take good and careful note when solving with a minus. So now we're going to start with the numerator, and then we have this. Opening these matrices out, we have this. Remember, D1A2 minus A1D2. That's how we got everything here, following the laws of matrix. Same thing applies here. B1A3 minus A1B3. As easy as that. So then we bring it out here like this, and we bring it out for further work. Okay, so this is going to be a little bit taxing, as you're going to multiply these two brackets together to have a long bracket. But it's easy to multiply. I bet you it is way easy to multiply. Very easy to multiply. Just to explain further, we have this. So how do we multiply these two? We take it carefully. Taking this first part here, we multiply it with everything that's here. Let's go. We now say D1 A2 multiplied by everything here. So we have B1 A3. Please don't mind the writing, but I hope it's clear. So this is how it's going to be. And then we continue. So this is equals to this times this minus this times this. Let's go. But another thing to note is that when multiplying, for instance, D1A2 times B1A3, A2 is first. Oh, welcome back. Sorry for the short interruption. So when multiplying, we have D1A2, B1A3. You know, we're going to take it in a very numerical order. So we say A2, A3 when writing it anyways. So now multiplying these two, we'll have A2 A3 B1 and D1. So now we are through with multiplying these two things together. And of course, we bring our minus out and do the same thing. Multiply here and multiply here. Or rather, multiply this with this. And then we have A1, A2, B3, D1. And then we are done with this part. So we move over again to this second part rather, and we multiply. Welcome. So Like I said earlier, having these, we're taking this, multiplied with this, and then we get this. So next thing to do is to take this and multiply with these brackets here. And then we have this, bringing it out. So let's go on multiplying. Remember, minus is key. So we have minus A1, A3, B1, D2. Sorry for the space there, but now we've multiplied these two together. We move over to this. Remember, minus times minus will give us plus. So A1, A1, B3, and D2. A1, A1, B3, and D2. So that's it. In multiplying these two brackets, we have this. And then we join the two together. Remember, we have this here plus this here. So we bring them together and we proceed. Having known how to multiply these two brackets, we proceed. We have this, 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 and this, all for this part. And then notice this minus t comes down here, and we do the same here, having these together. Now, we open up the brackets. It's essential. And please be careful, as there are a lot of minuses here that can disturb your solution. And then, opening up the bracket, we have this. Oh my. So sorry about that. Yeah, we're back. Sorry about that slip of the hand. We open up the bracket and we have this, taking note of the minuses that are around, causing an obstacle. And then if you notice that there are like terms around, if you notice like terms around everywhere, spotted, like terms are around everywhere. But at the same time, before that, see this particular thing and this particular thing. They are literally the same thing, only that one is positive and the other is negative. And it's like saying plus 1 minus 1, which gives us 0. And then, having that done, we have this remaining. And then, if we look at these closely, we see that A1 reoccurs in every place. Now, of course, we eliminate A1 by dividing everything here by A1. And then we have this. And of course, it's time to rearrange our brackets. There are a lot of things in the brackets, like terms and all that we have to put together to work. So now in rearranging these brackets, we have a lot of like terms and we put them together here like that and it goes on. Remember, this minus is still here. So we're going to divide through by -1 so that this minus can go away into the Neverland. And here we have this left. Looking closer again, there are still like terms we can factorize out. And then we have this, this, and this after collecting our like terms. If you notice, inside the bracket, this matrix law applies. And then we bring it out in the matrix form, having this, this, and this, with our factorizing elements outside. Bringing these matrices together, we have this. And then this is just for the numerator. Remember, we are not close to being done here. So this is the numerator. Now coming to the denominator, we have the same thing, remember? Come here, we open the bracket and all of that. Here, let's apply. This is what is in the matrix. We've opened it up. We opened it bigger. Taking note of the like terms around, we eliminate the two that are the same, leaving us with this. We divide through by A1 because it's recurring everywhere, leaving us with this. And from here, we rearrange the bracket according to like terms. Seeing that there are a lot of like terms, we arrange them according to the like terms, leaving us with this, this, this. Here, the matrix law still applies. And then we work on it and bring it out in matrix form. But if you look at something, in matrix, usually it's plus, minus, plus, or minus, plus, minus. No, sorry about that, so sorry about that. It's plus, minus, plus. But here, we have minus, plus, minus. So we can move forward literally. But guess what? We can divide this by -1 and we can get our answer in the suitable way we need it to be in. That is this, 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 and this. With the minus factorized outside. Bringing it to matrix form, we have this. Remember, the minus outside. And then we've had the numerator to be this and the denominator to be this with the minus. So bringing them together, this is the value of z. But that's not all. They told us that z is going to be in this format. So we still have to work on it further before we say we are true. Here, is the subject of formula, so we need this minus to be outside. And we need it to look exactly like how we were told to make it look like. So in doing that, we multiply both sides and we get this. This now, if you remember at the beginning, we have this change in 1, change in 2, change in 3, and change in 0. And we said they are equals to this. Remember? And z over change in 3 is equals to minus 1 over change in 0. Taking a look at this, change in 0 is this, and change in 3 is like this. So we move. If you notice, after cross multiplying, we have z to be over this and minus 1 to be over this. And thankfully, the denominator here is the same as changing 3, and the denominator here is the same as changing 0. That is to say, we can liken them to be this, and then we have our answer according to what is in the question, according to what the question demands from us. But you see, we still have 2 more variables to get before we can say we are true. So we're just 1 out of 3. So let's proceed for y. We're going to go through the same process again, but this time we want to be eliminating z. And instead of going all that far to the beginning of the beginning, we will just pick our R1 and R2 and solve and get the value of y by eliminating z. Remember, multiply these two equations by their inverse of the coefficients. And then we have this, making it in matrix form. And then we have this and this. Subtracting the two equations, we have this. Sorry for the interruption. So, subtracting both equations, we have this. Totally, we have this. We are going to be good, right? We're going to be good and faster, since we already have the basis from the solutions of how we got z. So it should not be harder. It's getting y and x. We take the numerator as usual. And then we solve. Having this, we open the brackets, get this. On getting this, we eliminate the one that are opposite to each other, that is this and this, leaving us with this. We divide through by a1 since it's reoccurring in every of them, leaving us with this. Then we rearrange the brackets according to the like terms that we have. Then this minus is still here and we don't need it. So we multiply it by -1. So it can go away. And then we have this. Collecting like terms as usual, we'll get to this. Now we have it in the matrix style. And then we put it in the matrix style, leaving us here like this. Are we following, please? That's that for the numerator. We have the same for the denominator. Here, we do the same thing. Open the bracket, cancel out, divide through by A1, which is recurring everywhere, and then we get this. Then we rearrange the brackets, collect the like terms, leaving us with this. And then putting it in matrix form, we have this and this. Then we bring both the numerator and the denominator together, and we have this. Of course, opening it up, or rather, cross multiplying. Cross multiplying and making y to have a denominator, we have this. But remember, our question says -y is equals to -1. But in our final answer before, it doesn't have minus. So what do? We multiply both sides by -1. Is that clear? And then we have this. Being that we have a format to put our answer in, we will go with the format given. Then we go with this. The denominator here is equals to change in 2, and the denominator here is equals to change in 0. So we have this. And we work with it. Since being that it's the same with the formats given. But then we have for the y. Then for x, we will have to go to the beginning, to the very first two equations, as they are the ones that contain the x variable for us to work with. Remember, when we're getting z, we eliminated x. When we're getting y, we eliminated z. Now we want to get x, so we eliminate y. Is a thing. So now, as usual, we multiply the equations by the coefficients of the, and then we have this. And of course, after getting this, we subtract these two equations, and we are left with this. Opening these brackets up, like factorizing the needful, we have this. I decided to rename this equation W1 for easy reference. Coming back again to get W2, we come back to the beginning stage as usual, and we have this. Multiplying the equations by the inverse of their coefficients, and then we subtract both equations together, and we have this. So we have W1 and W2. We bring those two equations together. We have this like this. But this is looking a little bit clumsy and difficult to comprehend. So we put it in a matrix form for easy understanding. After multiplying with the inverse of the coefficient, we have this. And of course, we need to eliminate z out, so to say, so we can get, or rather, we've eliminated y, but we need to remove z so we can get x to be alone with the constant. So when we subtract, we have this, z would have gone away. We're now left with this, and of course, subtract and carry on. After subtracting, we have this to be our x, but we can't end here knowing that we have a format to put x into. Now let's take the numerator and solve. We have these, bring it in bracket form, and we have this. Opening the bracket up, we have this. This. But some things still have to go away. Like now, this is positive and this is negative, so they cancel out each other. You don't need them anymore. Cancel them out. Cancel them out. You don't need them because they will give us 0. Canceling them out. Okay, we've cancelled them out. After cancelling them out, we are left with this. But we see B1 is recurrent everywhere. So we divide by B1. We rearrange the bracket, leaving us with this. And we see this minus is there, but we don't need it. So we throw it away by multiplying through by -1. We now have this. But of course, I can still see some like terms around, knocking around. So we collect them together and put them in shape. But you see, leaving it like this, it looks so clumsy. And then we have this in matrix form for easy comprehension. And of course, overall, at this. Now we take the denominator and we do likewise. Open up the bracket. Open it more. Cancelling the needful here and here. Oh, sorry. Here and here. Then we get this. But we can still see, as usual, B1 is recurrent. So we divide through by B1, leaving us like this. We rearrange the brackets in terms of like terms. Then we collect these like terms together, and we have this. Remember, if this minus was inside it, it will affect what is here, and it will not be suitable for the matrix law. So we factorize it out, bringing it out like this so that we can put it in matrix format, giving us like this. So this is very clear, I believe. And now we bring the numerator and the denominator together, and then we have this. And of course, we have a format that we want to fulfill. So we bring it into the format by cross multiplying, and we have this. Remember, this is equals to changing 1 and equals to changing 0. So these two can be likened to each other, and thereby it's correct. So having what we have, this is equals to this is equals to this, and this is equals to this. We can now say that this is equals to this, and can be further simplified as this. And then we can fully say that solving simultaneous equations with 3 unknowns is possible, especially using the matrix format. I hope you enjoyed the lesson and you understood all that has been said. I pray that the good Lord will grant you more insight and revelation into this that you have listened to, and at the end of it all, you come out successful in all your endeavors and it will be useful in your studies. Have a lovely day, have a lovely time wherever you are, doing what you know how to do best. Good things, remember. And of course, don't forget to subscribe to this channel, like this video, and share this video with all your friends and families. And of course, tell them to do the needful, as I mentioned earlier. Have a lovely day. Have a lovely time in God's presence as His peace and joy abides with you all. Amen. Bye. See you next time.